Sir, you can have a small description regarding your PPT and you can start, sir.
Okay. So today my topic is enhancing geospatial data and also analysis for our civil engineering applications with machine learning approach. This is my today's topic. Generally, uh, as a civil engineer, we have different specializations. How our geospatial technology is useful to all other applications and all specializations. We would like to discuss this one. And also I would like to share my one machine learning technique using satellite images that I would like to share to you. This is about the small description. Yes. Yes, how many- Is it audible, sir? Now?
Yes, sir, it is audible.
Okay. So first I would like to start from our core branch onwards. We are all civil engineers. We know we have different specializations like structure, geotechnical, transportation, water resource, environmental, ocean engineering, and remote sensing GIS. That is nothing but you can consider as a geospatial technologies. So in a real time, last 1 decade, geospatial technology is playing a vital role for all civil engineering applications. Earlier, only water resource and environmental type of issues has been uh, solved with the help of with the using maps and everything. But slowly it has been transportation applications and also geotechnical investigations. And recently, with the help of this technology also, playing a vital role in the structural health monitoring and those type of studies also. Mainly the remote sensing and GIS technology is playing a vital role to solve the problems. So we know uh, we already discussed what are the specializations, but how geospatial technology is solving the problems with relevant to that particular subject is just a few things I have mentioned. You can go any extent with the help of these tools also. For structural health monitoring, we are using the LiDAR data and drone-based data, and also mapping, and you can analyze the things for structural health monitoring aspect too, and some other things also. For geotechnical engineering, we can also map the spatially how the soils are placed in different locations, in region, in country or district, whatever it may be. How the soils are varying, and that level also we can map with respect to some soil investigation studies also. We can map the entire things. So how it is useful for means you can assess some landslides, earthquakes. So with respect to geotechnical aspect. So water resource hydrology, it is for water to delineate the watershed delineation. Water means how much soil erosion is coming from upstream to downstream, and what is the runoff. With the help of some other tools, we can predict. But remote sensing GIS data is base data to predict all these things. For any water resource studies, for watershed delineation or flood risk assessment, groundwater monitoring, rainwater harvesting, and remaining other studies also, you can use our remote sensing GIS data. For compared to our environmental engineering, what is the water quality at a different location? Suppose if you collect water samples at different locations in one district, you can analyze these samples and you just add that attribute information to each sample where you collected geospatially. Means with the help of some GPS instrument or with the help of your mobile also, you can capture the location. Just you drop on that map. Just if you take one district, just you collected 100 or 150 or 200 or 500 samples. Just you collect every location where you have collected that. Just you plotted on that. With the help of that, with the water samples data like pH, EC, TDS, BOD, COD, all these parameters, if you add with the help of tools, inverse distance weightage method, you can map the entire district. How the spatial it is varying, and how it is changing from June to December months, and how different parameters you can map, and you can also apply to soil parameters also the same thing. So this is one of the useful tools for environmental as well as water resource applications also. For transportation engineering, if you take generally what we will do, you can collect the samples at one road intersections, or you take one region wherever the roads are there, intersections are main important places, you are collecting the data. But students do not have any kind of geospatial data. Geospatial data means whatever the region they are surveying, they have to capture the road network from the labs and then take printout. Then you have to locate where you are collecting, what is the traffic volume at a different location spatially. So once you collect that data, then you integrate it into GIS form, then you can analyze the several things. What are the diversions you can suggest? What are the road expansion you can suggest based on those suggestions? So these are the very much useful things of information to us. Academia as well as that kind of information is not only useful to for publishing the papers or anything, but it is also useful for society applications also. How to divert our traffic volume studies, and traffic diversion, and at what time you can allow two way of these things to avoid mainly traffic jams and everything. So for that purpose, transportation engineering applications, it is very widely using these tools. So coming to next slide, sorry. So we are talking up to now, we have talked about how geospatial technology is playing a vital role in these our specializations. Coming to our point, what is geospatial technology? So it is a technology, it collecting the data, tools with the help of tools, we are preparing the maps and we prepare the geospatial database. So geo means, as a civil engineers, we know that what is geo? Geo means earth. On the earth surface, what are the features are there? We have to survey and we have to prepare on the paper map. Some suitable scale, we will prepare all the entire region, district, whatever it may be, area of interest, you can prepare. But what is your geospatial technology is playing here? Suppose one district map covers lot of roads, national highways, state highways, and different types of roads are available. But if you survey one entire district and freshly you are preparing the road network map in that district, it may take a lot of times, maybe 1 year, 2 years, 3 years, 4 years, maybe based on the team sizes and everything. Suppose if you use any remote sensing data, means a satellite data or aerial photography data or lidar data, sorry, any drone data. But satellite covers large area, so you can capture that information in the form of maps. We can draw entire district road network is very easy. Capturing the information from the imageries, very easy. Preparation of this database with the help of GIS softwares, it is very easy. So you can prepare that one, you can take some random samples, you can also check these things, and it is very easy to how much you have been mapped and all these things very easy. So, so that is the reason I'm saying that geospatial technology means it consists of different specializations in, sorry, these are the core components. These are the main components of the geospatial technology. It means each one is the different subject. So one is geographical information system, global positioning system, global navigation satellite systems, and sorry, remote sensing, radar data, unmanned aerial vehicle, and digital photogrammetry. These are the core of our geoinformatics subject or geospatial technology, if you consider. These are all the sorry, source to the GIS database. See, if you considering a remote sensing and digital photogrammetry or unmanned aerial vehicles or radar data, these are all the image format. So it takes some pictures from the above earth surface. So that is called your remote sensing. Remote sensing means you are obtaining the reliable information of the earth information with some distance. It is a continuous process. The radar images are, if you consider digital photogrammetry, it is an event based. Suppose one region is there, you can capture that entire region and then with the help of GIS softwares, you can map it and you can prepare the region maze. But you cannot get the spatial and temporal data. Again, you have to, with the help of devices, you have to capture. But whereas remote sensing, it is a continuous process. The images, acquiring the images is continuously. We are getting that images, we are analyze it, and we will do for our application purpose. So Earlier, before remote sensing, we used only digital photogrammetry. In the digital photogrammetry, it is extensively utilized in the Second World War to know the enemy's position. So later, it has been converted into societal applications also. So Colonel Lucedat is the father of photogrammetry. He invented that how to capture the aerial photographs for our civil engineering applications or civilian application purpose, how to develop, and all these things he has been developed. So that's why he is called as a father of photogrammetry. But later, once the technology is improving, slowly, what happened? We are sending these satellites into orbit. So satellites are a devices which are continuously revolving around the earth, and it is far distance. It may be 750 kilometer or 1000 kilometer above earth's surface. We are capturing the images so continuously based on the resolution. That is the different issues that comes later. But remote sensing is that we are obtaining the reliable information about the physical objects to some distant place. So these are the different technologies we are using for geoinformatics for mapping applications. Again, I will go next slide. Sorry. It's not. So again, I will go to, yes, this is the GIS point of view. GIS and GPS, GNSS, sorry to disturb you, because GIS and GPS and GNS we would like to share. For geographical information, sir, somebody is making some noise, please. Anil sir, somebody is making some voice, sir. Please stop that voice.
Yes, sir. Yes, sir. Yes, sir. I'm just verifying right.
Okay, sir. Okay, thank you. So coming to GIS and GPS, GNSS data, whatever the information we collect through GPS or GNSS, we can, whatever the stored data, we can directly transform into GIS softwares. There you can, whatever the collected information with the help of some devices, suppose a polygon information is there, suppose a water body is there. If you collect the water body feature with the help of GNSS instrument, then you collect that one, you just transform directly with the help of GIS software. So GIS is the vector-based things, and the remote sensing, LiDAR, photogrammetry, these are the image kind of things. So GPS are locational information, just handheld GPS, just like your mobile, how it is there. We can capturing the locational information. Same kind of the things we can capture with the help of GPS instruments. The accuracies are vary. For GNSS, you can get the centimeter level of accuracy of information. But the GPS instruments maximum or minimum you can get the 6 to 10 meter accuracy. That means if you, whatever the collected point information is there, if you draw one circle, within that circle, that point may be lies somewhere. But when with the help of GNSS instruments, we have to, some procedure is there. One is the base station, one is the rover station. With the help of this thing, some kind of enhanced things and corrections and everything what we can get. Finally, we will get the sub-centimeter or centimeter accuracy level. That means it is useful for cadastry and all these applications, cadastry mapping especially. So all these things with the help of GIS, we can prepare the things. So we know that GIS is the geographical information system, means you can store the data, you can retrieve the data, you can analyze the data, you can display the data, you can present your data. That is the GIS software usage. Generally, we have several GIS softwares are available and image analysis software. We have coming to our geospatial technologies, we have only two things. One is vector, one is raster. Without raster, you cannot do anything. Without GIS, you cannot do anything. GIS provides a lot of things with the vector related information. Remote sensing or whatever photogrammetry, these are pictorial information. So if you, with the help of GIS softwares, if you convert anything in the form of vector form, you will get the features information within KBs of data. Suppose one image contains 1000 MBs, 100 MB, 50 MB, 75 MB. It may take a lot of space in our hard disk. But when you convert that thing into vector form in our GIS, it may be very less space takes place in the our hard disk. So GPS or GNSS are also practical applications we are using. Mainly with the help of some theodolite instruments and total station, we survey the area, then we drawn the features, whatever the survey things we drawn on the paper map. But GNSS survey, it provides directly on the geodetic survey. Generally, whatever we surveyed and mapped, that is a two-dimensional thing. It is also, it doesn't fit on the maps also. So suppose if you use GNS instrument, it is directly geodetic survey. That means here, whatever the surveyed maps, it considers the earth curvature in that output. But with the help of total station and these instruments, if you drawn the any map or prepared any map, it we are not considering earth curvature on that our maps. But if you consider GNSS survey, directly it goes to the geodetic survey. So that is the main difference between the GNSS survey and our theodolite or physical instrument survey, whatever it may be, total station and other instruments. Right. So this is the components, how these are playing vital role in our civil engineering applications, how provides accurate position data for georeference. Where it is exactly lying on, because GNSS data provides a sub-centimeter level of accuracy. That means it is very much useful in the georeferencing of your satellite image or some other things. If you want to suppose one a regional area, some area has been changed drastically, some area has been changed a little bit. These kind of changes, if you want to map with the help of aerial photographs or satellite images, if you take high resolution images, then with the help of these things, positional accuracy and all these things transformation is very, very easy if you use these type of instruments in the field. So remote sensing, we know that drones data also last 1 decade, means 1.5 decade, UAV has been played very much in our civil engineering applications, as well as remote sensing studies and all these things also for crop monitoring and watershed assessment studies. And nowadays we are utilizing very heavily this UAV data. So digital photogrammetry is mainly used for three-dimensional models and 2D imageries. Earlier, whatever the maps we prepared by Survey of India, they used these photogrammetry techniques. If you two images overlaid, that overlaid portion, if you generate with the stereoscopy, you can view the 3D model. How the elevated portions are shown very effectively on the surface. So that they were mapped on the paper map, then they were transformed into topo sheets. So these are the very much useful to several applications, right? So one more thing. Sorry, I'm getting some difficulty in this. So again, I will share my PPT. Yeah. So this is the, if you look the one representation, what it is. See, if you look one picture, you may get remember very easily. Instead of telling 1,000 words, one good words is that one image speaks 1,000 words to us. So no need to say anything. What is GIS? What is remote sensing? What is GNSS? What is photogrammetry? I have shown these technologies with the pictorial form. That is the beauty of the image. How remote sensing can be obtained, how GIS can be useful, how GNSS is used, how photogrammetry it is. If you look this diagram, you can easily understand what it is remote sensing. With the help of sun energy, that whatever the reflected or emitted energy from the terrain, which is recorded by the satellites, that sends to our data center in the form of signals. Those signals we converted into digital images. So that is, we are using this as the image. So these images are very much useful to our many applications, like many, not only single application. You can do forest application, forest fire application, land use land cover application, change detection studies, transportation engineer, many studies you can do. This is the a core diagram of remote sensing. What GIS? With the help of GIS, what we can prepare? So what is the imagery? Just before this slide, I told several times, several words about what is GIS, what is remote sensing, what is GNSS. So if you look this diagram, you can easily understand and you can correlate whatever I told before in this before this PPT slide. So this is about GNSS. We have only three types of segment. One is space segment. We have different satellites in the uh, above Earth's surface, 20,000 kilometer above Earth's surface. These satellites are placed. These sends our signals to us, and this is called control segment. If any satellites are misplacing or some any because some gravitational forces, some changing sometimes in the direction of the path. So to correct and all these things, control segments will be helpful. So these are the user segment we are using that one. With the help of instrument, or you can use with the help of car. This car type of this thing we are using. Google Earth Maps are with the help of these things. They have captured the images of the every road they visited and how it is their surroundings are there. Everything they have been taken and they have uploaded. So that's why we are able to suppose we are here. Sir, please, sir, please. Echo is coming, sir. Anil, sir. Sir, user segment. So we have three types of this thing. One is airplane. Also, they are using because traveling from one location to another location with the help of this path only they are going. So and ships also same thing. And you this vehicle. This is the best example of Google Earth. Every person you know how to utilize this Google Earth. If you suppose view, you can direct now what buildings are there and what is the height of the building, that you can easily view, and you can also understand where you are going to that location or not, also you can able to understand. So this is the photogrammetry. Photogrammetry, these are we have to plan one region area, if you want to take, and you can take and just a flight path and what is the height, and we have to decide and what area capturing, how much area to be captured, and how much area to be captured in the image, means 10 by 10 square kilometer or 100 by 100 square kilometer in one image. So like that, we have to some flight path is there. Based on that, we have to survey, and we have to prepare, and we have to collect the images and prepare the for project planning. But this is only one event based. Earlier, it was used for cadastry mapping, but nowadays, cadastry level type means cadastry level means agriculture parcel boundaries are able to identify by the user. That is the task. This is a very important and challenging task in the remote sensing. Nowadays, that challenges are also reduced a little bit. Cadastry level of mapping, because crop yield or crop assessment or some other watershed relevant study, we can go for cadastry level. Cadastry level is the minimum level in the field, right? So this is the LIDAR, and another one is the GNSS instrument. This is GNSS, this is the UAV. UAV also you can unmanned aerial vehicle. You know that it is very much useful now to detect the enemy's position also. With the help of these instruments, we are also hitting the targets other side of our country also. It was happened latest in the Sindoor operations. You might maybe know. So this is the how unmanned aerial vehicle one schematic representation, right? Here this is the GNSS instruments, and also some unmanned aircraft data also, how it collects, and what are the components are involved, like that I have shown in this diagram. So this is the some ground control station. Earlier we have GNSS, same thing. Here also same thing. Sorry, this is some disturbance in my. Okay. Then next slide. Ah, So coming to our point, what are the satellites? What type of satellites we have? That we would like to know. One is the IRS-1C, 1D. These are the first in 95-96 time. It was used IRS-1C, 1D data. Rajiv Gandhi Water Drinking Mission project. For entire India, we prepared the groundwater potentiality zonization map of entire India. With the help of IRS-1C, 1D data is very much useful in that. So these are the general applications for with the help of the those satellites. What kind of applications we are going to do? And another one is it has some sensors. Sensors means nothing but cameras. These cameras, we have two types of cameras. One is LIS3 and PAN. Panchromatic data is a 5.8 meter resolution. WIPS is 188 meter resolution. That means resolution means 1 pixel size of an image. That is nothing but our spatial resolution. In terms of our spatial resolution. LIS 3 is 23.5 meter resolution. That means in the ground 23.5 by 23.5 meter. That is nothing but approximately 600 or 595 square meters of area. If more than that, only that captured by our satellite sensors, cameras, I can say. So these are the different other satellites, resource sat. I am concentrating only the Indian satellites. So resource sat. So this series has been started from the 2003 onwards. So they have introduced LIS 4. This is also color image, 5.8 meter, LIS 3, and other multispectral EVIPS data is useful for district series types of mapping applications. So these are some applications, and slowly the technology and techniques are improving. Our India is also grown very much. So ISRO is also developed one more satellite, Cartosat. Is a 2.5 meter resolution. Less than 1 meter data is also available, but that 1 meter is useful for military applications. That data, if any not restricted data, they are supplying nowadays. Earlier it was not done. So it is also useful for urban planning. You can able to identify very easily. 1000 meter ground level we can do very easily. 1000 meter, sorry, 1 meter level of mapping you can do very easily. For it is very much useful for urban planning, 3D terrain modeling, because for water resource applications, we need sometimes 0.5 meter contour interval. So for that type of digital elevation model is possible to generate with the help of Cartosat data only, right? This is the some photogrammetry techniques they were applied to generate the digital elevation model, right? Sorry. I'm sorry. Yeah. So coming to our geospatial, see, this is also one more satellites I would like. I'm sorry because some disturbance in my is. So please bear with us. So one is the ocean chart. Suppose if we are getting cyclones and some other times where tsunamis, so we have different satellites. For ocean sat is that only for monitoring of oceans and where the chlorophyll is there, chlorophyll more in that sea, oceans. See, entire ocean is a water body. You cannot identify anything properly. If you look on the only water only come. But ocean satellites are able to identify where the uh, chlorophyll, these things are there because for to supply that data to the fishermen. So with the help of that, where is the possibility of the fishes maybe accurately you can that. With the help of that, if they were supplied to the fishermen. So that is the data useful. Suppose sometimes the ships may be missing. Generally, human beings who may be missed sometimes or vehicles may be missed. But in the ocean also there is a possibility ships also sometimes missing. To monitoring that one also, these satellites are very much useful because ocean is very big. Our ship is very small. For identification of the things, very tough job task. So for mainly, we have to analyze the what you call multispectral data, microwave remote sensing data, and this data side by side. If you analyze, then you can get the where it is missed, and there's the possibilities we can identify. So reset, actually reset is the aperture data, C-band data. It is based on the wavelength. We have C-band and L-band type of wavelengths which is available to us. So mainly useful for flood mapping, agriculture. In the beauty of the reset series is that even synthetic aperture radar, we can collect the data at any time. Even night time also you can collect the information about the earth. So another one satellite which I would like to tell you, hyperspectral remote sensing. So these are the advanced remote sensing, I can say. Hyperspectral remote sensing is also very much useful for detection of some minerals, exploration, vegetation means how much green body existing on the earth, like that, environmental mapping and some rapid change detection studies also. So coming to our point, up to now, we have been discussed about what is civil engineering specializations and what are the geospatial technology and that technology, what are the things involved, we have been discussed. But coming to our point, geospatial visualization means whatever the raster data sets means, which is providing by satellites or aerial photographs, anything in the form of images that we have to convert into GIS form with the help of some GIS softwares. We have wide variety of GIS softwares. So ArcGIS is one software, Quantum GIS is one software, ERDAS is image analysis software, eCognition is also uh, image analysis softwares, AutoCAD Map, NV, Map Info. You can do raster as well as vector analysis in the same softwares. So any data, any geospatial visualization means with the help of these softwares only possible. So you can view 2D model and 3D models. 2D, 3D. Earlier in ArcGIS, only you can use, you can prepare the 2D mapping. But 3D mapping, we have to use ArcSkin model. But in ArcGIS Pro, you can 2D, 3D in one frame. Earlier, we have two types of modules we have to use, ArcMap, ArcSkin. But nowadays, ArcGIS, ArcGIS Pro, using that you can use 2-dimensional and 3-dimensional in one software. So these are the main applications. You know that land use, land cover, already we have been discussed in that. I don't want to discuss much. So up to now, it is over. But coming to our picture, machine learning. What is machine learning and how it is useful for our GIS applications? Where nowadays it is very hot topic. Last 5 years it has been widely we are using, we are listening artificial intelligence and artificial intelligence. Every subject, this AML is occupying a vital role, and instead of previous work and the previous limitations, and it has how it overcome with the help of these AML tools. So already we told that for geo visualization of data, we need some ML tools. So we are preparing the geospatial database with the help of ArcGIS software, that is over. But how AML tools are helping to us? That is very important task. So these are the how we are extracting the features from the aerial photographs or satellite imageries, and how to correlate that data with the use of these tools are very important. So these are the predicted times. Okay, I will also share later. Okay, right. Sorry. Right. So after machine learning, Geo AI toolbox, which is I'm demonstrating about it in the RGS software, because some other softwares also same kind of tools, but different names. But I'm a little bit aware of this ArcGIS, so that I would like to share how AML tools are embedded in our ArcGIS software. Because ArcGIS software is a widely using tools for many academia researchers and the industry also. But Quantum GIS is also useful, but when compared to ArcGIS, Quantum GIS is not that much compatible. But I don't want to say, I'm not promoting the any ArcGIS or Quantum GIS software. Freely tools are available in Quantum JS. If those who are familiar, they can use. But sometimes while using these softwares, some compatibility to also to be there. So this is about the ArcGIS Pro Geo AI toolbox. It is a new tool. They were developed these tools. With the help of these tools, how we have to apply AI tools for text analysis, time series of data. Suppose we have different time series of data sets we have. So how AI tools and techniques to be applied to that. So where the tools are there, every time they develop new tools in different environment they keep. We have to search that one and we have to apply those things, and we can experience how Geo AI tools are useful to our applications. Earlier we are restricted to some we have done some applications, but we have been restricted because of some restriction. Means some up to that level only you can extract the information. But with the help of these, we can remove those barriers. We can also get more kind of the things of accurately. So that is the very important thing. Right. So this is the deep learning tools also available in the ArcGIS. So later, NLP tools and natural language processing tools also there. In deep learning, one is the classify pixels, pixel based, and another one's object based. They have given. If you do practice on that one, if you can know the advantage of the AI tools and models. So these tools are available in the geoprocessing panel. So in that panel, this is the AI toolbox is available. With the help of that ribbon, you can do these kind of analysis. But if your time permits, I can show one. Yeah, this is one task and how located different toolbars. Automated machine learning tabular data in ArcGIS. It is available in the GeoAI. So image-based deep learning, image analyst toolbar, it contains this two tasks. NLP, text-based analysis. If you want to do any text-based analysis in the image, GeoAI. So where the tools are available and get that one and you work on that and you will get the results. Then you can feel the experience. So these are the different tasks. Right. So a random forest is also embedded in the ArcGIS Pro. Earlier in the ArcGIS, that tool is not available to us. But we have support vector machine tool. It is embedded in the previous versions. We can do classify and you can get the accurately compared to other classification method. So that is the advantage of SVM. And slowly they were also embedded in the random forest. So, sorry, gone forward. Sorry. So these are the, sorry. I'm extremely sorry because my, today it is my fasting. So that's why, right. Okay, sorry for the inconvenience to all. So to download any satellite image, we have to, for Indian or any other content also, any other continent. For Indian continent, Bhunidhi website. Earlier it was Bhuvan website. Now it has been Bhunidhi website. We have to give some register logins and all these things. We can able to download the images. Then you can download the digital elevation model also. Entire India, they have digital elevation model is there. So Google Earth Engine is that this is also a free open sources. Google Earth Engine, which is developed by Google people, and you can download the Cartosat data, Sentinel data, and other even our Indian satellites data also. Suppose if you want to download Earth Explorer also. Earth Explorer also a lot volume of satellite images data archive in those websites. For that purpose also, we have to log in credentiality is required. Then you can download the spatial and multi-temporal data sets and you can work on those images. So earlier in ArcGIS, we used only the what you call .NET technologies. But nowadays, Python is coming into picture. ArcPy, with the help of ArcPy, they have been developed ArcGIS Pro. So that is the reason they have developed the random forest and other tools which is relevant to AML. So that is the possibility. When come to C#.NET, they are unable to develop those type of tools. But ArcPy, it is very easy to, because a lot of library supportings and all these things happening in the ArcGIS software. So they developed these type of things. Earlier it was some restriction is there. They are unable to develop because they need some more things. So now ArcPy came into picture. It removes some barriers for that. So that is the main advantage. In BIM models also you can develop in the ArcGIS. That is the main advantage. So what are the challenges? Up to now we have studied the advantages and all these things. But coming into our point, challenges. What are the challenges are there? Data quality and resolution limitations. This is a very important thing. But earlier, still we succeeded something. But even though we have some limitations. So for this purpose, we required some interdisciplinary skills. Actually, suppose any hydrological assessment study using a SWAT model, we have to input land use land cover, digital elevation model, and soil map of your study area. Later, whatever the things we have to provide the uh, weather parameters with the locational information only. So this is the point data, this is the spatial and temporal data. So if you integrate this thing, finally you will get run the model, you will get the enormous results to us and day wise, month wise, year wise, watershed wise, and all these things. For the analysis part, we required a water resource person. Up to run the model, we required spatial person. For analysis, hydrological parameters, hydrology person, and suppose if any sediments which is carrying the pesticides and fertilizers information that is analyzed by agriculture person. What are the chemical components which are affecting on the soils and all these things by chemical engineers? Like that, it is a interdisciplinary. GIS is not single this thing, but integrate 2 or 3 persons of knowledge is very required for these applications. Opportunities in real-time monitoring and smart cities. It is also now CRDA also very much using the drone data as well as GNSS data. These are a very helping tool to prepare the urban mapping and all these applications. Right. So these are my final conclusion from my studies. Machine learning is geospatial analysis capabilities. We know that. So future lies hybrid models like AI assisted and planning. So earlier we have not unable to do. We have done some manual things. Now with the help of these tools, we can develop so much things. Okay, this is my topic. So if you would like to see some image and these things, that one also I will show in the ArcGIS software. I think it's a 910. Okay, if you time permits, I will show you. Otherwise, it is right.
Any doubts, sir?
Any doubts, if you may ask, sir, please. Sir, anyone having the doubts?
No.
Okay, thank you.
Okay, sir.
So
Thank you,
if you
sir.
have
Thank you,
any,
Dr. Sridhar, sir.
okay, sir.
So the feedback link will be sharing today in the WhatsApp group. From tomorrow onwards, we'll be sharing it in the chat box only. So due to some technical reasons, today we could only share through the WhatsApp group. And please fill the thing and have a nice day. Good night. Thank you. Thank you all.
Thank you.